Toby Keith, it's about 18,000 square foot steel and concrete building. The Alley Cat Oyster Bar is a 2-story building, it's about 8,000 square feet. It's got a nice little deck up the top, you can look out over the water. And then of course, the well-named building 4. It's about 500,000 square feet, it's 8 stories. The first story is all retail, it's mostly restaurants. Second story was parking, and then as you go up the building, in the middle, there's a big donut, so you have, I think, 8 stories of luxury apartments, and they are beautiful. On the footprint, building 4 is right about 100,000 square feet, give or take. We're going to use rough numbers, so we're going to call it 100,000. Chemicals of concern. You guys know this, right? We're on the East Bank, Chicago River, and Cleveland. It's pretty much all of them. Yeah. And here are our design requirements that were handed to us by the EC. We need to constantly prevent VOCs from entering the building. The solution had to be repairable by general contractors. And of course they want lower no maintenance. It had to be energy efficient. We had to coordinate the installation with all the other trades. And zero ability to make adjustments after the installation. The coordination part it's a little different on new construction because when we get into most brownfield buildings that are getting ready to be redeveloped, we're usually the first person to come in and we see a building at its lowest point in its life cycle. So if there's a pipe in my road, I just cut it out because they're going to put a new one in later. Here, everything's new, so we have to play nice with the other trades and make sure things fit where they're supposed to, no problems, and we all get along. Now, when I say zero ability to make adjustments after the installation, that is the grand total of the available piping on the first floor. That's it. There's no more anything exposed, no ability to make adjustments, no, oops, I don't have enough pressure field here, or the system's not performing the way it's supposed to over here. Okay. Other project requirements. This was a design assist project, not design build. We know the difference? Best way to talk about it is design build. You design a car, you build it. In design assist, you design the wheels and the tires for a car, you put them on a chassis, you push it towards it's going, and you design the rest of the car as you're getting there. We were building the first floor, they were designing the 8th floor. I got a call one day, we said, Tony, how much should we put a night story on this thing? What's it going to cost? And I was like, all right, okay, you're just playing with the new guys, it's not fun. But they had, honest to goodness, at one point decided we might want to put a night floor on this place. That didn't happen, but those are the kind of things that happen in design assist that don't happen in design build. We have weekly coordination meetings that we had to attend. I think out of 15 months we were on the project, in ththose meetings I said maybe 2 minutes worth of anything. So it was a great way to check up on my union. This was a union labor project. Now, when I say union labor, I mean it had to be union labor because the union had some money tied up in their pension fund in these buildings somehow. So they were part owner. They got to say whatever they wanted. Now, we at A to Z, we were an open shop. We work on everything from a single-family residential to a building this size. It's very hard for us to stay competitive if we were a union shop, so we pay union labor on union jobs, and other places where we can, we do as well. Each building was built by a different construction company. And then building 4 had 9 different restaurant build-outs on the first floor. Now, out of those 9 build-outs, they were completed by 5 different concrete contractors. So, not only did we have to oversee the installation, but we had to oversee it several times. We had about 8 or 9 different concrete contractors we dealt with, and I'll be honest with you, some of them were much better than others. But we all know that. Okay. Here's a picture of building 4. Each one of those colors represents a different floor. Some of them floors have been in multiple days, but that just shows you how cut up it is. Here, this red part in the middle was parking. That was done pretty early on in the process. Then we got our driveway upstairs. This one here actually started out as a different thing, and halfway through the build, they changed tenants. And the rest of it's all retail around the outside. So the first thing we had to do is we had to decide, there's a couple more seats up here if you guys want to put it in. We had to decide what the needs of the client are, and what the needs of the building are, what the needs of the regulators are, and then make a decision. So there's two basic categories in new construction sub-slab systems. They are passive systems that work via the stack effect. Warm air rises from the soil to the roof via system of pipes. That's pretty simple. They don't necessarily have a fan motor attached to them, and they work best when the temperature differential between inside and outside is greatest. Active systems, on the other hand, they utilize a fan assembly to create a negative pressure field where the ground level concrete meets the soil. The fans run continuously for the life of the building or the remediation project. Like, I don't know many remediation projects that end anymore. It seems like they just keep going. Okay, so passive system highlights. Now, the typical passive system has vapor collection matting spread out on about a 20-foot grid, and they just go over the entire footprint of the building. Most of them have a spray applied 60 mil vapor barrier installed by a specialty contractor. There are more than one type out there. There's different flavors. Some of them are wonderful, and other ones are just good. And then we have 4-inch PVC vent stacks are typically associated with them, and they're spaced about every 8,000 square feet. They're designed without exhaust blowers, and the only way to know if they're actually working is to do indoor air sampling. So, contrast that with an active system. The vapor collection mattings are about on a 60-foot grid, which means there's about a third as much vapor collection matting. We can use a 12 mil sheet applied vapor barrier instead of a spray-on, and we can have a concrete contractor do that if you watch them. And then in this large building, we were able to upsize to 8-inch PVC pipe instead of 4, which means less pipes going through the building, more gross leasable area for the architect. He's happier. We're a little happier. There are exhaust blowers incorporated into the design that run on electricity 24/7. One of the biggest things about active systems is we can go and we can actually measure the pressure field underneath the slab whenever we want to tell us if the system's operating the way we want it to. And if somebody just did their dry cleaning and starts to walk through right when we're doing our sampling, it won't bother us one bit. We're not going to chase any ghosts. We'll be able to know if it's going to work or not. So as we went down through that, our major points of emphasis here, we just threw it up on a grid like this. The most number of advantages is the system we like to go with. An active system is going to have the advantage on the matting because there's less of it. Suction fits where the actual pipes connect to the matting system. There's going to be more of them on the active side, so that's actually an advantage for a passive system. The vapor barrier, it's both 1,000 square feet. The difference here on the passive side is it's spray applied. And that's a specialty contractor. And when we're dealing with a big building that's got a whole bunch of restaurants on the first floor, what do they say, about 50% of restaurants fail? So they bring in a new restaurant, they got to cut the floor. Now they can either have a sheet applied vapor barrier that we can go back and repair with the general contractor, or we can have a different one that's spray applied. We have to bring in a specialty contractor every time they change the restaurant. That cost is not small. It can be very large. So it's a factor we have to look at in our system. Now, fan assemblies are going to be any fans in a passive system because that's how you know it's a passive system that doesn't have a fan. We're looking at about 4 of them on the big building. So there's an advantage of passive. Consistently effective.